Hello. I hope you enjoyed the keynotes. I hope you are enthusiastic. This session is going to be about automating security and compliance testing for infrastructure as code for DevSecOps. This is a pretty long name that combines lots of different methodologies. In this session, we're going to build a DevSecOps pipeline. We're actually going to build two different DevSecOps pipelines. And we're going to talk from high-level conceptual stuff to drill down to the code level. I hope it will be an interesting ride for all of us. My name is Roy Feintut. I'm the co-founder and CTO of Dome9 Security, an Amazon advanced partner with security competency, and as of yesterday, also networking competency. OK. So to summarize what we are trying to achieve in one word, the goal is agility. Agility is now a key to have better performance than our competitors. From security standpoint, in order to achieve that, we want to push security and compliance as early as we can into the developer lifecycle, right? So this is kind of different from traditional model, which is usually kind of stuck way back in the pipeline. So we build our software, test it, deploy it to some environment, then run all our testing, unit tests, application, acceptance test, and then comes security at the end, where an issue here sends this entire process back to the beginning. Another kind of side effect of that is that it puts too much pressure on the security team. So now all the business, the application owners, the business owners are kind of enthusiastic to push their application into production, but putting a lot of pressure on security that now are kind of a choke point for this entire organization. So new application, changes to existing application, all falls under into this bottleneck. So the idea is now that we have our infrastructure in the public cloud, infrastructure as code. So just before I continue, I want to synchronize on the terminology. When I say infrastructure as code, I mean that 100% of our infrastructure is codified. And not only that, we're using kind of standard templating to our infrastructure. To put it in perspective, I will be addressing CloudFormation templates. If you are a Terraform shop, you can take those same concepts with your Terraform deployments. So our infrastructure finally is code, is a template. So the idea is to apply coding best practices to our infrastructure as code, right? So because it's a code, I can test it as code. I do not need to deploy these environments into production, into another environment. I can test the code as code in order to gain security and compliance findings. Now, we've done that in the application realm, application development realm for many years. We have, unit test, and we have static source control tools. But this ecosystem for infrastructure code is kind of in its infancy. OK, so let's have a plan. Our plan is a multi-stage approach to tackle these challenges. So first, we want to prepare, right? So on the preparation stage, we are defining a core set of industry best practices, all our regulatory compliance regulations, security controls, and our own kind of internal core policies. This is usually something that probably most of you have already in some kind of forms, Word documents, Excel spreadsheets. So that's the preparation stage. Now, at the commit stage, we are talking about what happens after someone, developer, DevOps, committed an infrastructure code, a CFT template. And the idea is to treat it, again, just like any other application code. So we will test the CFT itself. without any need to provision any environment. At the live stage, we're going to deploy a live testing environment and perform our test over there. So this is the power of the cloud. I can spin up new environments in a matter of seconds or minutes most of the time, and then do our testing over there. At the end of this pipeline, we're talking about the production system. So there, we're going to have this continuous security and compliance assessment for our production environment. From responsibility standpoint, we are talking about two different cycles or two different cadences for this. First, we've got this DevSecOps pipeline, right, which is this sanitized, clean pipeline to push good quality code into production. So the commit stage, all the testing there, the live stage, and even the deployment to production stage. But then there is another cycle of the production system monitoring. And then we want to have an always-on monitoring that operates in its own cadence, continuously. So let's drill down into those different stages and some pros and cons. So doing some tests at the commit stage, infrastructure unit test, or the CFT, static validation, well, from pros perspective, this is the fastest and cheapest way to do it, right? This is something that is measured in seconds. And theoretically, and not theoretically, practically, this is the closest it can get to the developer. And again, we said we want to push security and compliance as close as possible to the people that write the code. So it can be integrated, again, as part of our pipeline. It can even be integrated as a Git commit that will operate on the developer workstation, and even as a IDE linter plugin, okay, theoretically. You cannot get as closer to the developer as an IDE plugin. On the con side, it's pretty difficult to do it right now with the existing tools, and maybe not everything can be statically reasoned about. On the live test, we're talking about, again, deploying a temporary environment and running tests over there. So it's a live system. We can do every test, right? But on the con side, it is slow. It is measured in minutes, and if you have experience with deploying large CloudFormation templates with lots of maybe bootstrapping, it could be many dozens of minutes. And also, there is lots of mechanics and moving parts, especially if you want to integrate other third-party tools that needs to synchronize with that environment. It's just adding much more moving parts. So, yeah. At the production stage, this is the ultimate resource that we're trying to protect, right? So every tool, third-party, library, project you'll find is designed to assist you with tackling these challenges. And the idea and the importance of this stage is that it covers everything, right? We cannot guarantee that every change to production will come from our sanitized pipeline, right? If someone enters this Amazon console, or someone with a root user, or whatever, or an API, a DevOps script that someone by mistake, oh, I didn't mean it to go to production. So this is why we have this extra or different mechanism to guard our production system. On the con side, it's again another suite of technologies that we need to master. And mostly these tools cater for the operations, GRC folks, and not necessarily for developers. And now a professional-looking graph that represents my view regarding the future viability of those technologies. So production monitoring was important in the past and will be important in the future. But I think that as we, as the ecosystem, will mature in harnessing this static code testing of our infrastructure, this will reduce the need to do this kind of complex machinery of spinning up new environments, running those tests, and we can get much better agility and again, reducing the complexity. Okay, enough talking. Now it's time to build something. So our first DevSecOps pipeline is going to be based on a blog post by an Amazonian named Ramesh Adabala. Not sure if he's in the audience. He might be. So the idea of this implementation is that it is 100% native Amazon implementation. So it's using only AWS native tools. At the core of it, there is this code pipeline. But again, if you're using something else like Jenkins, all of these concepts are transferable. So we have this code pipeline as the mastermind of this thing. The input for for this pipeline is an S3 bucket. In your environment, it might be a GitHub repository. In this example, it's an S3 bucket that our developers are pushing this code, this infrastructure code, this CFTs files into it. The code pipeline picks it up and then forms 3 different steps. In the commit stage, we are going to run a Lambda function that will do static code analysis for the CFT template. Again, not deploying anything, reading the CFTs file, trying to get insight from them. If we are happy, we'll continue with the flow and move to this testing stage. In this stage, we're going to deploy a new test environment, a temporary environment. We're going to perform now live testing over that environment. There is an optional manual approval phase embedded in this solution. And at the end of that, we'll delete the stack, clean up those temporary resources, and push it to production. We'll create a change set and then execute it. So that's the plan. Now let's see it. Once I log in. OK. So this is the blog post. And again, it's linked in the presentation. I recommend you to read about it. We've also provided a repository of that is kind of stripped down and clean up version of that post. So the address is also, the link is there. So let's review what we have here. In this repository, we'll have these 2 examples, the V1, which we are doing now, and the V2. So let's read the instructions. So basically, we're going to create 2 VPCs in that account. And we'll create an S3 bucket. And let's start doing this. So I already created 2 VPCs in my account. I've created an S3 bucket named reinvent SID317. OK. And OK, so let's review the source code here. So in V1, we have 2 folders: the code pipeline Lambda, which contains our code. So we have this CFT validation for phase 1, and the stack validate Lambda for this second live test. And we've got my application itself. So you see my app, which for this sake of the demo, it's the most simplistic one. My app contains 1 security group with an SSH rule and 2 configuration files, which provides the needed VPC name or VPC ID parameter. So back to the instruction. So I have updated those 2 configuration files to match the VPC IDs that I've just created. OK, next is we're going to review the push scripts and update our S3 bucket name. I've done it for you. S3 reinvent and S3 reinvent. OK, now that we did this, we are ready to go. We're going to use those 2 scripts in order to push first our pipeline code. This is something that we need to do once, unless we change our validation code, and then deploy our application. So let's do it. OK. OK, we're on V1. Push, validation, Lambda. Now this script zips everything and put it in S3. We're going to do a similar thing to push our application code. Bang. So we've created 2 zip files. They were already uploaded now to S3. And now it's the time to create a new CloudFormation stack using this the pipeline that is provided here. So this is pretty long CFT that provides our entire pipeline implementation. So if you remember in the past, our build servers were such a snowflake, a unique system. Now the fact that I can share this code with you, and all of you can have this same pipeline that I have, I think this is pretty amazing. Great times. So this is this stack formation is everything. It creates S3 buckets and roles and Lambda functions and DynamoDB and whatever you need to run this thing. So let's go to this CloudFormation and let's create stack. I'll use V1 code pipeline CFT. Okay. So the only thing I need to do here is provide a meaningful name. I can do something like that. Okay. Provide the bucket that I have already prepared. Reinvent. And my email. This stack also creates SNS topic and sends you a notification and communicates with you. So that's pretty cool. This is my email. Please don't spam me. OK. That was it. Next, next, next. And bang. I'll acknowledge that and create. I will not create it right now with you because for the sake of time, but it takes about 2 minutes to provision this entire thing, which is pretty nothing. So let's see this stack that I've already provisioned. Again, it creates a lots of interesting resources, pipeline, functions, DynamoDB tables, all sorts of things. Let's drill down into the actual pipeline that it creates. OK. So you see, the pipeline was already created, but I created that before. But it created and then starts to work immediately. So we see the commit stage, the scanning of those S3 buckets. So whenever I push something into this S3 bucket, this pipeline will pick it up. Then we'll do this static CloudFormation testing. If OK, continue with this test deployment phase. Right now, as you see, we are progressing. I've just uploaded. Remember when I uploaded the app? So this pipeline picked that up. So now we've passed this CFN CloudFormation template parsing. Now we are deploying a live stack environment. We're going to test it in a minute or so, and once approved, we'll go to deploy to production, all automatically. I want to review those 2 Lambda functions, this stack validation and this CFT parsing. So let's get back to my code. Remember, the lambdas, the validation lambdas are here. So I won't do everything. We'll not review every line. Let's just get the basic gist of it. So the lambda, this is the lambda handler. You see it's a Python lambda function. Let's review it quickly. So just extracting some parameters. OK, boring, boring, boring. Still boring. OK. Now we're setting an S3 client in order to get this CFT template. So eventually, that function is gonna get to this Python function, this CFT that we're about to test. The next step is get rules, which provides the list of rules that we're gonna evaluate against. Where these rules come from? Good question. The author of this project has separated the validation logic into DynamoDB. So now you don't need to maintain those rules inside that function. You can maintain them in DynamoDB, add and remove rules as needed. So this is pretty cool. So as we see, I hope that you see. Yeah, it looks fine. Basically, it loads these rules from DynamoDB. Thankfully, it provided some kind of starter rules for us. Let's take a look. For example, this SSH open to the world rule. Again, it's from category security group. Right now, in that demo, there are security group and EC2 instance rules. You can, of course, add more types. And the rule data itself, this is the main kind of security compliance content. So again, ingress, from port, to port, blah, 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 22, blah, 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 000/0, and lots of other stuff. OK, so that was the rule. So we've got our rules. And the last function is this evaluate template, which basically just loads those resources from this template, and for each resource, grouped by type, we're gonna do so. Now for the security group resources, we're gonna match them with the rules, with the SG rules. So the main thing is this regular expression match, and we're gonna do the same for EC2 resources. So if you're gonna adopt this, I recommend to just refactor that a little bit. I feel that it can be generalized a little bit. I don't like code application. So I guess it can be more generalized and operate on many kind of resource types. OK, so that's pretty cool. And the last step is again next step where this is the decision making if to continue to continue or fail the build or this pipeline. So there is a nice concept of risk. So if it's a low risk, we'll put success job. Basically, it's signaling this pipeline to continue, or we're gonna signal the pipeline to quit. Okay, so that's the CFT validation. Now moving to a completely different world, which is the stack validation. So this is now, again, the function that's doing live validation of an environment. So here we're gonna kind of implemented an interesting concept. So it's got kind of a controls array, and they got numbers and control 4.1, which again basically is just a Python function. So let's see how our rule is implemented there. So now we're using completely different technology, right? We're using the Amazon SDKs. Boto library, and now we're gonna describe all the security groups. We're gonna filter only the ones that are relevant to our stack, and we're gonna implement the rule. In that case, the rule logic is to make sure that security group is on SSH rule is only open to this our NOC CIDR. So that's the concept of this implementation. So let's switch back to our pipeline. So we finished with those two tests. By the way, we passed those tests. And now this manual approval phase, again, optional for you. I can now review the stack, look into the resources, and say, hey, this is looking great, and approve that. So now I've already have this test my app, and which is the test environment. It will be very soon. It's going to be deleted. OK. Let me switch back to my presentation. OK, so we've been able to complete level 1. We've got a fully working pipeline that received this CloudFormation, testing it, static code test, live code test, and then deployed to production. So we should appreciate those and celebrate those little wins. So let's have it. and thank Ramesh. OK. But now it's time to take the red pill. I know it looks easy, right? It took us 15 minutes to get to this place. But reality is much uglier, right? This super easy CloudFormation stack is not what we're going to experience in real world. So now we're going to actually see the downsides and the complexities of that solution. The first thing I want to talk is RegX. RegX or RegX? I don't know. RegX, I'll say. So this is the rule that matches the SSH is open to the entire world. I find it pretty difficult to read it. And even if I wrote it, a regular expression is considered as a hashing function. You can write it, but you can never read it back. So, so I cannot read it. And by the way, I've injected 5 errors into this rule, which I cannot find which are they. So the suggestion here is, actually it's multiple suggestion. Don't use regular expression for this kind of JSON to reason about JSON. That's nice on paper. This is not maintainable thing. So either use a general purpose computing language, JavaScript or Python, or even use there are now some community project. I hear some companies using CFN NUG, if you're familiar with that. Or if you are a Terraform shop, then there is Terraform Sentinel, which allows you to reason about your Terraform templates and put rules into that. So these are much more oriented technologies to do than doing this thing. The next challenge with CFTs are the dynamic templates. Right? CFT is not static. CFT is flexible and dynamic. It's almost like a programming language. We've got parameters, either user-defined or injected by the runtime system. We've got functions, intrinsic functions. We've got conditions, branching. Again, I don't think it's Turing complete, but it's very close to it. So let's see that in action. This is difficult to read. The rest of the ones are smaller. In this example, wow, it works for you guys. For you guys. So in this example, we have, I need to get closer too. We've got this bed SG1, which the from port and the to port are not static number like 22. These are actually find in map function that search in this hash table or in this mapping. And what's the key to search for is also named app, is also a user configurable parameter. So in that case, if the user has selected the bastion parameter, then it will resolve to port 22. So it's try to use your regular expression against this thing. Another form of dynamic templates is the condition. So here, you can probably read that. So we have this condition, create dev resources. So in this case, our regular expression will fail this rule, even though it's never going to get to production. So that might be a desired thing to open SSH to the developer, although I do not believe in that. But still, it might be desirable, and in this case, we'll get a false positive by our regular expression test. OK, to help you with this solution, there is a little gift or a little thing you should be aware of. We have created that for our internal use about a year ago, called a project called the CFT Simulator, which allows you to take this highly parameterized, conditionalized template, provide parameters, and then this simulator will evaluate parameters, evaluate those intrinsic functions, follow the conditions, and then output the resolved template without any flags or everything, a concrete template. So now you can take this template and feed it to whatever testing logic that you want to have. So this is an idea for you. The next thing I'm going to talk is multiple representations of the same outcome. So the same endgame, the same outcome, can be modeled in different ways using CFT. Why? Because the syntax permits that, and also because we have some default implicit behavior of the runtime itself. When I'm not defining stuff, still there is some default behavior that happens. So let's see that in action. I'm not going to read it to you. You can review that. But this shows how many ways to control the IP address of an instance. So we can have an instance resource with an embedded network interface resource. We can have an instance resource with another root level network interface resource that is referencing this instance. We can have an instance, a network interface, and another network attachment entity, another network attachment resource that will tie those two together. So now that we had all those ways to connect this network interface to the instance, now how do we determine the IP address of that network interface? So again, it could be part of the network interface with the associate public IP address, or we could have an elastic IP resource that is then referencing, or an elastic IP address that is using another resource like elastic IP association to connect that. Too much. And on top of that, we can have something that is not even defined on the instance or NIC level, which is a subnet property, which is called map IP on launch. So again, if you want to reason about CloudFormation, you need to be aware of these things and search for all these kind of patterns. You need also to be aware of the things that you don't see, which are attributed to the default behavior of the runtime, the CloudFormation runtime. So in this example, I'm going to show you this bad SG4. And this security group actually has 0 properties besides the description. The bad stuff comes from external security group ingress rule that opens SSH to the entire universe and then is referencing that security group. OK, the last thing I want to talk about is actually understanding the domain that we want to reason about. So in that case, this is 2 very common misconfigurations that we see. At the first example, someone has copied our NOC CIDR 1.2, 0.3, 0.4, but then added a /0, where effectively this is as good as opening it to the entire internet. On that example, someone has opened a security group to a port range from port 20 to port 30. Now try this regular expression on that security group. The last challenge that I'm going to talk about is this multiple technologies challenge, where we're having, again, I'm going to use this one. I like it better. So we're going to have this Word or Excel spreadsheet for the human beings, where we define our policies. We're going to have the technology that we reason about our CFT, our static code. In this case, it's the regular expression. We're going to have this live Amazon SDK code with Java, JavaScript, .NET, Python, that we're going to reason about our live environment. And we're going to have a plethora of tools to help us protect this production system. Again, it's CloudTrail, CloudWatch, CloudWatch events, config rules, our SIEM systems, our security configuration monitoring systems, all this a huge array of tools that will help us guard the system. So that's pretty much a Babylon Tower. So let me now introduce you to GSL, Governance Specification Language. This is a purpose-built language to reason about cloud security and compliance. We have developed that at Dome9 in order to assist with tackling this complex challenge. At the core of it, there is a domain model, a cloud domain model, that pretty much is very similar to the Amazon model, but it is oriented to reason about the security. So this is why we can add all sorts of properties, helper things, and restructure it in order to make it efficient to be queried. On top of that, there is the GSL, the language, and the runtime, the policy, the rule engine, that allows you to write these rules that then reason about this model. A few examples of those rules are security group where name is default should not have inbound rules. Instance should have tags with key equals owner. Security group should not have inbound rules with the port 22 and the scope 000. I don't need to tell you what these rules do. I think you can guess it by now. So this concept of a concise, human-readable policies, these eliminate all those errors and this kind of mismatch between the security and compliance folks and the developers, because now many more people can join into this brave new world of software-defined security and compliance. So the next implementation of our pipeline, V2, is going to be based on that technology. So we're going to utilize a few key capabilities of the system. So first capability, it's actually number 2, is the capability to run assessment on a live environment. So we're going to use that via API in order to reason about our live environment. But before that, we're going to do static code analysis using the same compliance engine. So what's happening behind the scene is pretty clever. Because of this intermediary model, so now we can take this CloudFormation, run it through all the simulators, build this unified cloud security model, and then allow you to reason about it just like a live environment. So it pretty much mimics most of the implementation that goes inside CloudFormation, but the engine does it for you. And then on top of that, we've got this always-on continuous monitoring for the production env. Now, all of these are driven from the same GSL policy file, all these 3 different technologies. So to understand this pipeline, it's based on the same pipeline that we've seen, but now we're getting all the DynamoDB and the rules and the regular expressions and those bot tests, and replace them with a single API test, a single API call to this compliance engine. So we're going to have this CFT validator that will use this CloudFormation assessment API. We're going to have the live assessment that is going to be using the live assessment API. And on the side, we're going to have a continuous compliance policy that will always scan the production system. So we'll see that in action. So I'm switching to the V2 part. And let's follow up the instructions. So first, I'll skip this create an account. Oops. It will be better if you'll see it. So yeah. So I'll skip the creating an account, but now we're going to create our first policy. So we can create a new policy, which I'm not going to do because I've already created one, reinvent session. And now we're going to create rules for this. We're going to create rules for this policy. So I can type in the rules, but I can use the rule builder. So in that case, I'll create a rule like security group should not have inbound rules with, the port 22. And the scope is 000. You know what? But we are smarter than that. We know that it's not the most robust thing. So we'll do something even better. So we'll do that the inbound rules do not contain the port. Now we'll do less than or equal 22, and port larger or equal than 22. That will catch all those port ranges scenarios. Now, in addition, remember all those misconfigured CADRs. I'm not going to string match it to 0000. So we're going to do a port and use some reasoning about it. So the port is public, and the port number of hosts that are exposed by that. The scope. Number of hosts larger than 256. This sounds like a large number. If it's more than that, I consider this as publicly exposed. Okay, so now I can name it, add a description, remediation, and that's it. So we are done with our first rule. I've already created that, and we are done. I will just note the ID of that bundle. So now we're going to deploy the same thing. The same process, we're going to deploy this CloudFormation of this pipeline in JSON. I've already done that for you, so let's review that. The only thing that I want to show you is that it's basically the same thing, that we've just added one more parameter, which is the bundle ID. Okay, and now I want to run my new CloudFormation template. So I'm going to test my real-world application. So this is the ugly one, right? With all those problematic security group. Security groups again, SG1 with the mapping, and bad SG2 with the misconfigured CIDR. So that is the. Okay, let's push that. Okay, so now I'm pushing this new problematic app to production. From code perspective, I've kind of covered that. So it's very similar. The Lambda tests are pretty much like those previous Lambda tests. Just the fact that we've removed all the need. We removed the need to do all these regular expression, and instead we just validate it. We just validate it against the DOM9 API. Another interesting thing here is that now we are getting another parameter, which is production CloudFormation parameters. We want to simulate the real production workload. So we're taking this CloudFormation, we're taking the production parameters, and then feeding the engine with that data, because we want to reason about the CFT that will be deployed to production. So that's basically the thing. So now let's take a look at our pipeline. Okay, so we've seen that the S3 hook already got this CloudFormation, and now is feeding that to our new function, the CFT parsing function. We see that it's in progress. Sometimes it takes some time for this code pipeline the UI to refresh. So now I see this little details link, which sends me to this CloudWatch logs, which is tied to this Lambda function. So I can review here the Lambda function, and actually it took it 3 seconds to do this entire test. It might take the pipeline a few seconds to detect, and now we've detected a failure. So let's click on these details. So CFT validation failed, high risk detected, and I've got the failed rules that we just created, never expose SSH to a large public scope, and also in order to assist us, we have this link to the assessment itself. So it's much easier to read it like that. So let's review that. So I see I've got one failed rule, because we had one rule in this template, and let me expand that, and we see this bad SG 1, 2, 3, and 4 as being highlighted to me. So let's review that. So remember the first SG with the port found in the map. Eventually, it got transformed. It got transformed to the same normalized model. Inbound rule with TCP 22 open to 000, and it got failed. The second one was misconfigured CIDR whitelist. So remember that 1.234/0? Well, it exposes more than 256 addresses. So this is why this rule failed. The third rule was a port range issue, right? So we had port from 20 to 30, and it was also detected because we planned against it. The last one is inbound rule that was defined externally. So again, at the same end, it is transformed to this same unified model. So you don't care that it was defined in a different way in the CloudFormation, the end game looks just the same. And this rule failed. What you don't see here is the good SG, because it was not deployed to prod. So this is why we do not get this alert. So yeah, so I'm pretty happy that the demo went well, and we can celebrate this next success. Yeah. So first, I would like to thank you for attending this session. We still have time for Q&A if you'd like to stay and talk a little bit about that. And you are also more than welcome to the Dome 9 booth. Yes? The code repo is private. I will open it just after this session. Thank you. Thank you all.